So what you will learn: find n roots of numbers, evaluate expressions with rational exponents, solve equations with n roots. So let's come to a definition of a raised to 1 over n. If n is any positive integer, then a raised to 1 over n is equal to the nth root of a. Now, the provision in here is this: provided that the nth root of a is a real number. Real number. So cube root of 35 can be written as 35 raised to 1 over 3. Fourth root of xy can be written as xy raised to 1 over 4. 5 raised to 1 half can be written as the square root of 5, and a raised to 1 over 5 is written as fifth root of a. More examples. 4 raised to 1 half can be written as the square root of 4, which is equal to 2. Negative 8 raised to 1/3 can be written as the third root of a negative 8, which is equal to negative 2. 81 raised to 1 over 4 can be written as the fourth root of 81, which is equal to 3. And this is going to be a special case because what is only raised is only the 9. It's not really on the negative 9 as a whole. So we can write that as the square root, negative times the square root of 9, which is going to give you negative 3. Definition of a raised to m over n. So if m and n are positive integers and 1 raised to 1 over n is a real number, then a raised to m over n is equivalent to saying a raised to 1 over n, and we're going to raise it again to m. Now, using the radical notation, we can simply say that a raised to m over n is equivalent to the nth root of a raised to m. So this is the big idea on this definition of a raised to m over n. Example, 8 raised to 2 over 3. This can be written as 8 raised to 1 over 3, then raised again to 2. Let's proceed. That's going to be cube root of 8 raised to 2. The cube root of 8 is 2 raised to 2, and this is going to give you 4. The other one is going to be 81 raised to 1 over 4 raised to 3. So that's going to give you the fourth root of 81 raised to 3. The fourth root of 81 is 3 raised to 3. That's going to give you 27. The definition of a raised to a negative rational exponent. If m and n are positive integers, a is not equal to 0, and a raised to 1 over n is a real number, then a raised to negative rational exponent is equivalent to 1 over a raised to m over n. Now, using a radical notation of the same expression, then we can also say that this is going to be equivalent to 1 all over the nth root of a raised to m. Write each expression in radical form. So the radical form of this is going to be 1 all over the fourth root of 5x raised to 5. Okay. Next, 10n raised to negative 6 over 5. That's going to be 1 all over the fifth root of 10n raised to 6. Last but not the least, this is going to be 1 all over the root of 3k raised to 5. So this is going to be the opposite of your definition today, and that's going to only give you 3k raised to negative 5 over 2. Okay, so let's simplify the following. So 9 raised to 1/2 is going to be the same as the square root of 9. The square root of 9 is 3. Next, 343 raised to -4/3. That's going to be 1 all over 343 raised to 4/3. And in its radical form, it's going to be 1 all over the cube root of 343 raised to 4. That's going to give you 1 over 7 raised to 4. That's going to give you 1 all over 2401. Okay, that's your final answer there. Okay, 36 raised to 3/2 is the same as the square root of 36 raised to 3. Square root of 36 is 6. 6 raised to 3 is going to give you 216. Okay. Okay, next, number 4. This is going to be a very nice one. 64 and 12 raised to -1/6 is going to be the same as 1 all over 64 and raised to 12 raised to 1/6. In exponent radical form, you're going to have the 6th root of 64 and raised to 12. That's it. Okay, if you go further, so that's going to give you 1 all over the 6th root of 64 is 2. The 6th root of n12 is you divide the exponents together. 12 divided by 6 is going to give you 2, so that's going to give you square. That's going to be 1 over n 2n squared. Okay, so I hope you understand these simple practices in our lesson today. To understand clearly about real nth roots of a, I would like to bring you back to your basic lessons of your radicals and its parts. So the nth root of a is actually what you call a radical. So let's look at its parts. Okay, then a in here represents the radicand. That's going to be the number, any number under the radical sign. That's your radical sign. And the n in here is what you call your index. Now the index is going to tell you what's gonna be the root of a. Okay, remember this one, a in here, the value of a can be less than 0, it can be equal to 0, or it can be greater than 0. For the index, I would like you to understand this very well. The index can only be either even or it can be odd. Okay, so the number of real roots is going to be determined by these two factors, the radicand and the index. So let's look at the real nth roots of a when n is even. So there is an invisible 2 in here, you have 6 in there, you have 4, and all you can notice is that they are all even numbers. Now let's look at a. A is the radicand, this one. Okay, a in here in this case is less than 0. -25 is less than 0. It means to say that there is no real root. Here our a is exactly or equal to 0, and then that means it's 0. Okay, here the 4th root of 16, our a here is greater than 0. It means to say that it has going to have 2 real roots. So if you're going to solve this one, the 4th root of 16 can be either plus or minus 2. It means to say that if you're going to multiply -2 4 times, it's going to give you positive 16. And if you're going to multiply 2 4 times, it's still going to give you positive 16. That's why it can be either plus 2 or minus 2. Now let's look at the real nth roots of a when n is odd. Okay, it's odd. So if you're going to be looking at these examples, 3, the indexes here are 3, 7, and 5. These are all odd numbers. Now let's see what will happen to the radicand, or we call it the value of a in here. Here, -1 to 5 is less than 0. Here, it's less than 0, it means to say that it only has one real root. So if we're going to solve this one, the cube root of negative 1 to 5 is negative 5 only. Okay? It means to say that if you're going to multiply negative 5 3 times, it's going to give you negative 125. That means one root really. Here we go. The next one is the 7th root of 0. Okay? Here, a is exactly the same or equal to 0. It means to say it's 0. Last but not the least, look at your a in here. Your a in here is greater than 0. 243 is greater than 0. So it means to say that it also has only one real root. Here, one real root. So if we're going to solve this one, the 5th root of 243 is actually 3. Okay? 3. Okay, you multiply here, it's equal to 3. If you're going to multiply 3 5 times, it's going to give you 243. Now, if you're going to multiply negative 3 5 times, it's not going to be a positive 243. It's going to be a negative 243, and still you're going to have one real root for each of these situations. I hope you understand this one. Thank you so much for watching.